Let's do two more examples. For our first example here, let's first make sure that we can use the difference of two squares formula. We have a binomial, two terms, and each term is a perfect square. But what about this sign? We have a plus sign here, but the formula is only for the difference. That means that it's tempting to use the formula, but we cannot. We cannot use the formula, we cannot factor out this expression, and that's why the answer to this problem is prime. We cannot factor it anymore. For our next example, let's also consider whether we can use the formula or not. It's a difference, so it seems that we can use the formula, and it's a binomial, but if we look carefully at each term, they are not perfect squares. So what should we do? Also put prime there? But wait, remember, I always advise you first to think about the greatest common factor before you use any other methods of factorization. And if you look carefully at both terms, we see that 2x is a common factor for both terms, and when we take it out, what is left of the first term is 9x squared minus 1. And inside the parentheses, a difference of two squares has emerged. We have two terms inside the parentheses, minus sign the difference, and both terms are perfect squares. So for this expression, our a will be 3x and our b will be 1. So we will continue factoring out. But please don't forget to carry on by the very end the factor of 2x. It will be part of your final answer. Don't just drop there as soon as you think that it fulfill its purpose. So carry on to the very end. And inside the parentheses we will have 3x plus 1, 3x minus 1. And this is our full final answer.